video is on P1.3, which is about pressure for the OCR 1-9 GCSE. The first 2/3 of this video are for combined science, and then the last section is for triple students only. So I will mention that when we get to that point. Okay. So what we need to be able to do is to explain how the motion of gas molecules, in a gas is related to its temperature and to its pressure. To explain the relationship between temperature and pressure. To understand that gases can be compressed or expanded, and that pressure changes a net force at right angles to any surface. Explain how increasing the volume of the gas at a constant temperature can lead to a decrease in pressure. That is Boyle's law, so being able to explain Boyle's law. And explain how work can be done on a gas. We also need to be able to apply some mathematical relationships within this as well. So first, just a general overview of pressure as a concept first. So when we think of pressure, we're thinking about a force divided by an area. So a pin, for example, has quite high pressure, snowshoes would be an example of something with a low pressure, right? So you don't fall into the snow. The pressure is force per unit area. The units are the Pascal. So Pascal is equivalent to 1 Newton per meter squared. And this is our equation right now. So that's the sort of general equation for pressure. Everybody needs to learn that equation for P2, but obviously we're mentioning it here because it's relevant to our understanding of pressure as a gas. So one other little thing I just want to add at this point is that one way they like to complicate this equation is obviously the force can quite often be my weight. So obviously weight is the downward force due to gravity, and so the equation for weight is mass times the acceleration due to gravity. So obviously the mass is how much of the object there actually is, kilograms. The weight is the downward force due to gravity. So on Earth, because the gravity is 9.81, we often approximate that to say that Earth's gravitational field strength or acceleration due to gravity is approximately 10 newtons per kilogram. It means for every kilogram of mass you have, you'll experience 10 newtons of force. That's the approximation. Okay. So this just shows you the difference between weight and mass. So mass is the inertia of an object, or how difficult it is to accelerate. Unit is the kilograms. It's also a scalar quantity, it doesn't have direction. Whereas weight is just an example of force, but specifically because of gravity. The unit is the Newton, because it's a force and it's also a vector, always downwards, because it has direction. So that's an application of how it can be linked to pressure. When we think about gases, or we think about like how would I blow up this balloon, like what's happening when we blow up this balloon, we could think about the number of particles, the collisions, the pressure. So what we'd be saying is that obviously as we're forcing more air into the balloon here, we're increasing the pressure. Well, what does that mean? Well, what we're doing is we're increasing the number of air particles inside the balloon. So there's air particles, sorry for the dodgy lines, are all inside the balloon, and they're moving around all over the place in different directions. And some of those air particles are going to be hitting the outside edge of the surface of the balloon. Also, the air particles on the other side are doing the same. Now, when we increase the pressure, because we increase the number of collisions on this side, the balloon expands until it reaches an equilibrium again, and the force of the gas, the pressure of the gas outside and inside the balloon is equal. So we're trying to explain a macroscopic effect. So that's something we can physically see. Macro is like in the large sense of the word. That's the pressure that we see in the balloon. With a microscopic explanation, we're thinking about how the particles are constantly moving around, colliding with the walls of their container, and that's what causes pressure. So pressure is caused when particles collide within the wall of their container and exert a force. And if we increase the temperature, you should understand at this point that temperature is the average kinetic energy of the particles. So if we increase the temperature, we're increasing the kinetic energy of the particles and therefore increasing their speed. So when they collide with the walls of the container, two things are going to happen. One, they're going to collide more frequently, which is a really important word to use. Okay? So the frequency of collisions is essential, and also that phrase is very important for chemistry as well. the frequency of collisions is going to increase. You're going to have more collisions every second because they're going faster. And secondly, because their speed has increased, the actual force of the collisions is also going to be greater because they're going to have a bigger change in speed when they bounce off and change direction. So if we were comparing these two cylinders, for example, we exert a force here, we're compressing the gas. So if we think about the differences, and you can have a think about this before we go through the answers, think about the differences between these and try and explain what is happening in this scenario. So if you've had a thought of that, what you should have worked out is that firstly, the volume is smaller here. Okay, the gas is spread into a much larger volume there. So as we decrease the volume, the particles come closer together, we have an increased number of collisions, and that is what causes the pressure to increase. This is analogous to the frequency of collisions that we talked about on the previous slide. So putting this together then, we get what we call Boyle's law. So this is the experimental setup for the Boyle's law. So we have a pump that's going to measure gas pressure, and we can see the volume of the gas contained here. We can measure how the volume of the gas changes as we change the pressure. So Robert Boyle did this and was able to work out the following: that for a volume of a fixed mass, so obviously assuming that's constant, that the volume of a gas is inversely proportional to the pressure exerted on it, provided the temperature is constant. So temperature and mass has to be constant, but volume of a gas is inversely proportional to pressure, which we write like this. What does this mean? Well, when we say inversely proportional, that's not a complicated thing. It just means when we increase the pressure, we decrease the volume, and vice versa, which should make sense if we go back to our previous slide, that when I reduce my volume, I'm increasing my pressure, because this is what we just explained. Volume is smaller, pressure is increased. So that's gone down, but pressure has gone up. Okay, so that's what all Boyle's law is. As the volume of the gas decreases, pressure increases. They are inversely proportional. What we can then do is we can make this into an actual equation, and we end up with PV equals constant. So if I do pressure times volume, that will always give me a number that is constant. Now, for combined students, it kind of stops there. Just on this bit, there is a little bit more in a second for combined students as well. But for triple students, you need to be more aware of this equation that shows the pressure at the start, the pressure volume at the start will be equal to the pressure at the end times the volume at the end. So you can rearrange this equation to work out a new volume if you've got the initial pressure and volume and the new pressure, for example. So when volume decreases, the pressure increases at constant temperature. They are inversely proportional. So temperature and pressure. If we heat up a gas, then the particles are going to move around more quickly because they have more kinetic energy. So that is also going to increase the pressure, because increasing the temperature increases the kinetic energy. It's going to increase their speed, more collisions with the container. So they're going to be more frequent collisions and more energy. So particles gain more kinetic energy, they move faster, they increase the frequency of increasing the force per unit area, and therefore increasing the pressure. The pressure and temperature are directly proportional, which means that as one goes up, the other goes up. The keywords we've just covered so far would include these. So you should be aware of all these keywords and how they relate to what we just talked about. If not, go back and have a look at what we just covered. And then we move on to atmospheric pressure. So here are just some definitions just for atmospheric pressure. Feel free to have a look at those. Some other bits of C1 as well. J.J. Thompson. So the next bit that we need to know, and this again is for all students, combined and triple, is about atmospheric pressure. Describe a model to explain it, and why does it vary? Okay. Basically, the Earth, which you can see here, so the Earth is the black bit, has a very thin layer of gas surrounding it, which is our atmosphere, and it is very thin, right? 480 kilometers might sound thick. It really isn't, right? When you look at the world as a whole, you can see actually how it is just literally described as a thin blue line, and all of that thin blue line is where all the gases that keep us alive are situated. So this is what our air is made up of in terms of proportion. So it is 78% nitrogen, 21% oxygen, about 1% argon, only 0.034 or 0.035, sorry, which is why we round it up, percent carbon dioxide. So very small amount of carbon dioxide, and then a very, very small proportion of other gases like methane, etc. So that's what our atmosphere actually consists of, right? All that gas is sitting on top of you. So if we imagine all that gas in a column, right, of 1 meter squared, okay, here, so the area of this is 1 meter squared. We imagine that extending the whole way down, okay. By the time that you're the person standing here on the Earth's surface, the weight of all of that air is pressing down on you. So it exerts a pressure, just like it exerts a pressure on the ground, right, it is going to exert a pressure on you. So atmospheric pressure is the pressure exerted per meter squared by the weight of the air in the Earth's atmosphere, or if it's on another planet, it would be on that atmosphere. So if we relate this to like this kind of thing, it makes a lot of sense that, you know, who would have the most pressure? Well, it would be obvious that these poor souls standing down here have got the weight of everybody else standing on them. So as we go up, the pressure becomes less. So if we imagine this with altitude, where obviously is height, the higher we go, the lower the pressure. So the closer you are to the Earth's surface, the more pressure there is. So atmospheric pressure decreases as you increase your height, or it increases as you go down. So that again is an inversely proportional relationship, because as one goes up, the other goes down. So as altitude increases, pressure decreases. Okay, at this point, we're now going over to content that is triple only. So for combined students, you can stop there. For triple students, there's a little bit more to do, which is about pressure in fluids. Very similar to the atmosphere, pressure in a fluid, obviously the deeper you are in the fluid, the more pressure there is. Pressure increases with depth. So in terms of these holes in the jet, you can see we've got the strongest jet at the bottom, because there's more pressure acting down on it, so forcing it out more strongly, whereas this one will be the weakest jet. So how does pressure vary with depth? It's very simple. Pressure exerted at the bottom of a container is due to the weight of the water above it, in exactly the same way the atmosphere was. So at a greater depth, there is more water above, there is a larger weight, and therefore greater pressure. Pressure in a liquid increases with depth. This is linked, of course, to density. So more dense liquids will have a greater weight, because they will have a greater mass, a greater number of molecules, and therefore a greater pressure. If you imagine drawing the force of the water on the can, you can imagine that it is exerting a force on the surface of the can, like the balloon was earlier, and so it obviously there's greater pressure at the bottom than there is here at the top. Obviously there's no pressure from the water above the can, but of course there is atmospheric pressure acting down there as well. So there is an equation for this, which is a triple only equation, which is this one. So pressure of a gas, pressure of a fluid at depth is the density rho of that fluid times the height or the depth multiplied by g, which is n, the gravitational field strength for acceleration due to gravity. So this equation, very, very simple to use, right? So for example, if I've wanted to work out the pressure of some water, so water has a density of 1,000 kilograms per meter squared, which are per meter cubed. I would then times that by 10, which is g. Okay, so remember, pressure is density times g, times the depth. So let's say I wanted to know what it was at 5 meters deep, for example. So the depth or height is in meters. So obviously that's going to be 50,000 pascals. That's how much pressure there is if I'm 5 meters down in water, which actually is only half atmospheric pressure, because the Earth's atmospheric pressure is 101,000 pascals. So obviously if I imagine I've got some water. I'm 5 meters deep. I actually have my total pressure at this point is going to be the pressure because of all the atmosphere, which is that, plus the pressure because of my fluid as well. So actually it'll be 150,000 pascals in total. But if we're just considering the pressure from the liquid, then it's just going to be 50,000 pascals. Here are just some questions or some answers that you should be able to answer for this topic. Feel free to have a look at these, think about them. The answers are in black. So that's it for pressure. Any in this topic that you don't understand, please have a look back at and review before moving on.